Kids, welcome to the 5-minute science secret tips video. Three things we're going to talk about here in 5 minutes. One, genius mapping science passages, how to understand what the main idea is right away. Number two, arrows to help you quickly identify relationships because that's really the point of all science, the study of relationships. And three, a creative way to understand graphs. Let's go ahead and take a look at genius mapping. Kids, here we have passage number one. Let's go ahead and genius map it out. So in the upper left-hand corner, you're going to see that we have this mini introductory paragraph. All right. What I usually do is get the big picture from the last couple of sentences. All right. Usually they'll give you some background information about what they're doing, but I usually will start here. And I'm not saying always I don't read the whole thing because this is kind of an important passage paragraph. When you read this stuff, you want to focus on trying to get out the main noun and the main verb to determine the amount of light absorbed by a solution. Okay, so we have a solution. That's going to be our noun. I circle it, and then light being absorbed by it is going to be the action. Okay, so when you come back over here, now in the tables or the graph, if you have an XY graph, what you could do is just come over here and a genius map tells you you're going to circle on the tabletop of a table trial. So trial is either going to go to the noun or the verb. So you have trials, and what are the trials testing? They're testing light absorbance. Okay. Over here we have temperature. Okay. So is temperature light absorbance, or is that part of the solution? What is being temperature is being raised or lowered? Is that the absorbance, or is that the solution temperature? It's the solution, the temperature of the solution. See how we just kind of make some small little assumptions? Time is going to be the time, and the absorbance will obviously go to absorbance. All right, that's our map. Oh, okay, I see. Now you come over here, acetone concentration. It's pretty easy. That's going to go to solution. Okay, and then absorbance goes to absorbance. Okay, that's our map. Okay. Come over here, methanol concentration, that goes to solution, and then absorbance goes to absorbance. So you see, now it's really easy for us to understand how this passage is mapped together. We have different concentrations of different things, okay? And then what happened is we're just going to test the absorbance. Now here it never really tells us that we have some type of a solution. So maybe one of the questions may ask you about that. You would have to come up here and see exactly what is the solution in experiment one. What are they doing? So that would be coming from the text area. Okay, genius mapping for science. Number two, arrows to quickly identify relationships. Why is this important? First of all, the study of science is really just the study of relationships. As I do this, what happens? It's either going to increase, it's going to decrease, or there's going to be no effect. All right, so we want to quickly identify that. Okay, when we use our arrows, we are going to use the arrows specifically when we have charts of numbers, okay? And what we are going to do here is we're going to simply go ahead and draw an arrow all the way up or down the column of numbers, just to the right or the left of the numbers in the column. I'll show you in a second, okay? And what I do is I always shoot the arrowhead, okay? So here's the arrowhead. Here's the arrowhead here, and here's the arrow. And I always shoot from the small number and then draw the arrow pointing towards the large, okay? So if I have the large number here, the small number is here, I would shoot my arrowhead from the small to the large. Remember, the arrowhead should always point to the largest number in the columns, okay? So this is going to help you identify right away what the relationships are, and it's going to be so easy for you to see when there's negative numbers, what's going on with the relationship. In every one of the passages, for the most part, you'll be asked a question about relationships. So here we have three tables, and you can see that here is distance, diameter of the star, and the diameter of the telescope. Right away, if we were in a genius map, we would simply circle these and then relate that back up to the last sentence or two in the mini paragraph. That will be in the upper left-hand corner. All right, that's our genius map. Then what we would do is we would come over here and we would just simply identify the relationship. Okay, so remember, we're going to take and find the small number and draw your arrow pointing to the large. 2 and 8, so here's the small number. I simply draw my arrow like that. Okay, now over here in the next theta, I find the small number. The small number is here, 0.4, and I draw my arrow going up to 1.5. See that? That tells you that the relationship is inverse. When you come over here, let's find the small number, 7.5 and 30. Draw your arrows like that really fast, and then small number where it is right there. Now, in this one, you see they're going to ask us a question about this because this is the relationship here is going to be direct or the same, whereas it's opposite there. Okay, and then over here, small number 2 to 10, I draw like that. And then here's the small number, and I draw like this. Okay, so you see right away, you see that we have two inverse relationships. Okay, the diameter of the telescope versus r is going to be an inverse relationship. Diameter of the star and theta is going to be the direct relationship, and then the distance in theta here is going to be the opposite. That's how you're going to go ahead and quickly identify what the relationships are. Draw arrows, point your arrows in the direction of small numbers going to big, and just do it right off to the left or the right of the columns of numbers. And finally, number 3, creative way of understanding how to interpret a graph. Before we get into this, we have to talk a little bit about brain psychology. Okay, so here's your brain. And you know, your brain runs off of electricity. And we are not connected by a cord to any wires or anything like that. So what happens is we eat food and water, and we convert that in a very, very inefficient way in order to convert electricity. Okay, so your brain, did you know, runs off of 5 watts of energy. And if you want to know what 5 watts of energy looks like, just simply look at the bulb in the lamp that's right in front of you right now, and you're going to see that the wattage on that bulb is probably 100, okay, just to give you that amount of energy. Now think your brain is a supercomputer that runs off of 5 watts of energy. They're going to give you a graph or a chart, and when they put the XY axis here, know that they're doing this in a way that's going to mess with you in regards to just what doesn't make any sense. A common way is to give you something that looks like this, you know, 0 to 100, and this Y-axis deals with depth. And then maybe this is going to be our temperature. So we've got depth versus temperature. So your brain knows that when you think of depth, your brain thinks down, right? But it sees the chart like this. So even though your brain is cognating and making some quick, super fast assumptions, your brain is seeing this, and it's causing that extra amounts of energy. Maybe just by doing that, that is plus 1 watt of energy. Well, if the question entails long questions already, and they're already up to 5 watts with that, then just by flipping this chart around gets you over the 5 watts. Remember, anything over 5 watts of energy equals confusion. Okay, so what you want to do is you want to basically take this chart and you want to just rotate it. Okay, so see something that makes sense. All right, so here we have a typical example of what I just talked about with overloading your brain with extra info. Here we have the depth, relativity, and then we have the CO2 content. All right, when you look at this and this just doesn't make any sense. You see here, this goes from 0 down to here, and then these numbers just get kind of weirded out. So what we could do is we could come over here and we could just go ahead and try and rotate this, okay? So when you simply flip this 90 degrees, now you see that we've got the depth here. As you're increasing the depth going in this direction, you see it kind of jumps up, and then it goes down, and then it jumps up, and then it goes down. It's quite a bit easier to see. You see, in general, it kind of goes like this. So that's still kind of a relationship that's direct, even though there's some dips. So much easier to see and understand what's actually going on when you simply just take your ACT test and rotate it clockwise or counterclockwise or maybe even 180 degrees. Kids, that's it. Thanks for watching. Remember, Genius Map, the last sentence or two from the mini introductory paragraph at the top. Arrows whenever you see columns with charts of numbers. help you quickly understand what the relationship is because there's always going to be a question. And then a creative way of understanding your graph or your chart. What you want to do is just simply rotate it either left or right to orient it to make the chart more understandable for what your brain quickly is going to make an assumption about. Kids, thanks for watching. Good luck on your practice test today.